Oh, welcome back. We are on triangle similarity by side, 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 and side angle side. So again, we're adding to our toolbox these shortcuts to show that we have similar triangles. So again, instead of showing that all three angles are congruent and all three sides are proportional, we can use these shortcuts. Remember last time was angle, angle, and now we're going to learn side, 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 and side angle side. So it's super similar to when we did this, I don't know, a couple months ago for proving triangles are congruent, but now they're just going to be similar. So let's talk about side, side, side. So side, side, side similarity is if all corresponding sides are proportional, then we don't have to worry about those angles. We'll just automatically know we have similar triangles. Again, if you have three pairs of proportional sides, then that is enough to say we have similar triangles. SAS, our favorite side angle side similarity, is if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. And we know that, right? The angle needs to be the one between the sides we know things about, that included angle. That's why it's side, angle, side. So again, two pairs of corresponding sides are proportional, and that included angle must be congruent to the other guy. And then we are good to go there for side, angle, side. So now we're just going to see some different examples of triangles and decide if they are similar by some of our shortcuts or one of our shortcuts. So if we look here, it says determine if the triangles are similar. If so, explain and write a similarity statement. Okay. So hopefully by now we can visualize that we have two different triangles here, right? We have that small guy AEF and triangle ACB. So if we look, I always like, again, I have my weird things. You guys know this. I'm going to look at my small triangle. And my small side here is 8. So I'm going to have 8. And now what's kind of goofy when you have overlapping triangles like this, you're going to think, oh, my small side is 4 on the big one. But you need this whole length. Like, what is that whole length of AC? That whole length of AC would be 8 plus 4, which is 12. And the whole length of that side is 15. So now if I look at this big triangle, which side's your smallest side? Well, it's 12. So I'm at 8 over 12. Reduce it, because we can, to be what? 2 over 3? So that's one pair of sides that are proportional. And then do you guys see how they both have angle A? So now I have an angle. Angle A is congruent to angle A. What property is that? Just for a fun fact. If you're equal to yourself, remember that's the reflexive property. And then our last side here that we need to compare is our bigger side on that small one is 10. So 10 over 15. And it does reduce to 2/3. Had we got something different here, guys, like let's say we got 3/4 instead of 2/3, and this would be a no-go. They would not be similar. But since we have two sides that are proportional, they have the same scale factor, and the included angle is congruent, they are similar. So we're going to say yes by side angle side similarity. And now we write our similarity statement. So triangle, I'm going to do E, A, F. Now we match. C matches E, A matches itself, and F matches B. There we go. Done. Deal. All right. Determine if the triangles are similar. If so, explain why and write a similarity statement. So again, we have two triangles here. So I'm going to outline this guy on the left and this guy on the right. So we're going to have the purple and the green triangle. Ooh, that did not go so well, but you guys get the idea. So on my purple triangle here, what's my smallest side? That's how I always start because it's the easiest thing for my brain to do. 16. Now what's my smallest side here? On the green one, it's also 16. So 16 over 16 reduces to 1. Okay, now I'm gonna hop back to my purple triangle. On my purple triangle, what's like your medium, your middle side length? That would be 18. And then my medium middle side on this guy here would be 30. If we reduce that, we're gonna get what? I think what, 6 goes into both of those, so 3/5. Ooh, you guys, did we get 1? No, these have different scale factors, so not the same, and we needed them to be. So since they're not the same scale factor, this would be no, not similar. Not similar. Again, another problem here. So remember when I said whenever you have like those intersecting triangles like that kind of look like a bow tie, we get those nice vertical angles. So we have an angle pair. So we're probably thinking this is going to be side angle side, but we have to make sure our sides are proportional. So if I look at my triangle on the left, my smaller side is 10. What's our small side on the triangle on the right? It's 20. Reduce 10/20 to a half. Now we look at the next side over here is 11. The side over here that it matches is 22. And luckily for us, that does reduce to a half as well. So since these are the same, and angle TWZ is congruent to angle XWY, we have similar triangles. So yes, by side angle side similarity, triangle, let's do WTZ is similar to triangle W, T matches Y, X. Perfect. Good work, team. And then our last one here. Determine if the triangles are similar. If so, explain why and write a similarity statement. Okay, excuse me. So, start on my small triangle over here. What's my smallest side? Well, it's 6. What's my small side here on the triangle on the left? It's 8. We reduce to 3/4. All right, your middle side, your medium side is 9. What's your medium side over here? It's 12. 3 goes into both of those, right? So we do get another 3/4. So far things are looking okay for us. Now your longest side on this small triangle over here is 12. Our longest side on the triangle on the left is 16. And hello, you guys. These are all the same. So we do have similar triangles. So we're going to say yes. By side, side, side similarity, we have similar triangles. So I'm going to say triangle MPQ is similar to LKJ. Now this last one, they want us to figure this out if they're similar on the coordinate plane. So yes, there is some distance formula action that needs to happen. However, I don't want to do that alone. We might do it in class, we might not do it in class. We will decide when I see you next. So actually, we are done with notes for today. Have a super day, and I will see you when I see you. And that's it. Thanks for watching. We'll talk to you soon.